Assalamu alaikum, I am Kizar. In today's lecture, we will look at the 5G network slicing and then we will see network slicing solutions. In our previous lecture, we discussed what were the challenges we were facing before 5G, what basically 5G is, and then we looked at the 5G architecture. And in this lecture, we are going to look at 5G slicing. Now start the driving forces behind the network slicing. Here is an end-to-end network slicing. Basically, network slicing is a technique to divide a single network into the multiple virtual networks. In network slicing, we have access layer, transport layer, core layer, and services. On these different slicing techniques were like smartphone slicing, HD video slicing, Internet of Vehicles slicing, and security monitoring. What is the purpose of slicing? To agile and efficient development of diversified services means to make our system more flexible. Isolated slicing for higher service quality operates access to the vertical industries, low cost diversified service and lower TCO. RAN fundamental radio access network fundamentals, how it's work. In this example, we have two users, UE1 and UE2. Both are using electromagnetic wave to communicate with each other. UE1 will connect with the base station G0B through the electromagnetic wave, and G0B base station will then connect with the UE2 user 2. You want to communicate with UE2, it will send the message UE2, but first it will go to the base station, that will boost up the signal and go to UE2. Similarly, UE2 send the signal to the base station with power of the signal and send to UE1. In this way, they communicate with each other and using electromagnetic waves. We have two types of slicing. First is hard slicing and second is soft slicing. Let's see what they are. RAN slicing, wireless time frequency resources. Whenever we are slicing, we need three types of parameters. First is throughput, means large amount of data. Second is connection. Third is ultra reliable low latency. Here we have example. We have 3 floors. On C floor there are only 2 people. On floor B there are 4 people. But on floor A there are multiple people. Here's a difficult task how to slice these people on floor 1, then floor 2 and then floor 3. Means we can see in the picture the space is congested in A floor. Then we will slice our remaining audience to the floor B. In this way, if floor B is full, then we will arrange our audience into the floor C. In this way, we can slice. Transport network slicing. What happened in transport network slicing? As I earlier mentioned, in slicing we need all the 3 things: best bandwidth, ultra reliable low latency, and massive amount of connections. Here is an example that company A uses EMBB, enhanced mobile broadband. Want to communicate with company A. It will communicate through VPN hardware connection, and again here is an VPN, and here is the part of slice. At a time we cannot throw all these 3 things. That's why this slice each thing separately. First, G0B connect to the router then connect to the OTN, and on the receiving end OTN connect to the router, and router connect to the GW app. In this way, in transport network slicing done. Here we have core network slicing. We have control plane and user plane. As we discussed in our previous lectures, that In our core plane NGC, we have two type of planes, control plane and user plane. Here you can see the voice service. We have user plane and control plane which are working together, and then IMS, and here is an HD video whose size is 1 to 10 GB per second. Again we have UP and CDN and massive low latency. We have on the final stage we have CP and the user plane. This cloud shows the S data center, these clouds shows the regional data centers, and these clouds show the core data centers. When we arrange everything, you can say that on the receiving end the receiver is saying call is clear, no time delay, means everything is good at all. You know what is the difference between the services of 5G slicing and previous technology slicing? 5G improves the quality of service awareness, it reduces the cost, gives the new service and the more scenarios. The time frequency resources done in RAN, radio access network, and the bandwidth is done on transport network, and any function is done on core network. These all things we discussed in earlier lectures. Now, what is the network slicing solution? You know, two type of 5G networking, standalone and not standalone. 2014 to 2016, the 3GPP was a global initiative institute that worked for the 5G. Then 2017 and mid of 18 we used the function of release 15, and then 2018 and 19 we use release 16, and then in 2020 is commercial development. What is standalone system and what is non-standalone system? In non-standalone system, it is necessary to have a 4G core, EPC 5G G0B, or it can be 4G core 5G Node B or 4G E Node B. I discussed in earlier lecture, G Node B is the name of the base station of the 5G and E Node B is the name of the base station of the 4G network. Similarly, it can be 5G core and 5G Node B, but in standalone system we cannot use 4G core, we have to use the 5G core and next generation core plus 5G Node G Node B, or we can use 5G core next generation core plus 4G E Node B plus 5G Node B. Means in non-standalone system we can use 4G core, but in standalone system we cannot use 4G core, we have to use 5G core, but we can use 4G E Node B. 5G standalone networking condition, 5G core network deployed and 5G core network signal is sent directly to the G Node B. Means whenever the sender want to send a signal, it will send directly to the G Node B, as we see a few slides ago in example that UE1 will send signal to the G Node B, and then G Node B will power the signal and send to the UE2 user. Here we have dynamic distribution like EPC LTE, you know, the LTE services for the 4G and NR services for the 5G. You can see here is a user and here is an LTE network and here is the NR network. You can say here is 4G network and here is 5G network. You can see the clear see in the picture the 4G network is dropping the signal, but the 5G network has a completely strong signal. Too much transfer pressure to large scale upgrades the needed. And what is static distribution? Again we have LTE and R. You can see in the picture which is clearly defining in LTE network we have a much buffering, but in NR in 5G network we have a low buffering. And what is buffering? Buffering is a delay while you are using any internet thing, and it's all about 5G network slicing and 5G network slicing solution. If you like this video, then please like this video and share your questions and precious reviews in comment box. Please subscribe to this channel and hit on bell icon. Thank you.